All right, let's dive into a core chemistry skill that you are absolutely going to need for your test: balancing chemical equations. And I promise, once this clicks for you, it's going to stick with you forever. So let's get right into it.
Okay, first things first. Before we even think about touching an equation, we have to start with the one fundamental, unbreakable rule that governs every single chemical reaction you will ever see.
And this is it, the law of conservation of mass. This is our foundation for everything that follows. It's a really simple idea, but it's incredibly powerful. You know, in chemistry, you can't just make stuff appear out of thin air, and you can't have it just vanish without a trace.
And this right here is the perfect proof. Just look at the math. If you've got 8 grams of hydrogen and you add 32 grams of oxygen, you have 40 grams of stuff to start with. So on the other side of that arrow, you must end up with 40 grams of water. The mass you start with has to equal the mass you end with. There are absolutely no exceptions.
So, what does this law actually mean for all those chemical equations you're seeing on your test? I mean, why do your teachers keep going on and on about balancing them?
Well, think of a chemical reaction kind of like a recipe. The atoms on the left side of the arrow, those are your ingredients. They just get mixed up, they get rearranged, and they form the final dish on the right side. Nothing is ever lost or gained. You can't start with 2 eggs and magically end up with a cake that somehow has 3.
And that's the bottom line. We have to have a perfectly balanced scale. If you have 10 carbon atoms on the left side, the reactant side, you must have 10 carbon atoms on the product side. Now, they might be in different molecules, sure, but they have to be there. Every single one has to be accounted for.
Okay, let's get into the practical skill, the real how-to. But first, I want to show you the single biggest mistake people make. Seriously, if you can just avoid this one thing, you are way ahead of the game.
All right, listen up, because this is the golden rule. You can never, ever change the small subscript numbers, like the 2 in H2O. Why not? Because changing that number changes the actual substance. H2O is water, right? But if you mess with it and turn it into H2O2, well, you've just made hydrogen peroxide, a completely different and way more reactive chemical. We can only change the big numbers out front, the coefficients, which just tell us how many molecules we have.
Now, if you follow this system, every single time, balancing stops being this big, scary guessing game, and it just turns into a simple counting exercise. That's it. You just list your elements, count them up, use the big numbers to adjust, and repeat until both sides match. Okay, theory is great, but let's actually walk through this together with a classic example, making water. This is going to make all those steps crystal clear.
So here's our starting equation. Hydrogen gas plus oxygen gas reacts to form water. And, at a quick glance, it might look fine. But if we put on our law of conservation goggles, you're going to see there's a pretty big problem here.
And this little tally table gives us all the proof we need. Look, the hydrogens are fine. 2 on the left, 2 on the right. We're good there. But check out the oxygen atoms. We start with 2, but we only end up with 1 on the other side. In the world of chemistry, that's completely illegal. An atom has literally vanished, and we have to fix it. So how do we fix this? Well, remember the golden rule. We can't touch the little numbers inside H2O. Our only move is to change how many water molecules we're making. And to do that, we add a big number, a coefficient, right in front.
Let's try putting a big 2 in front of H2O. This tells us we're now making 2 water molecules instead of 1. Now, that 2 multiplies everything in the molecule, so now we have 2 oxygen atoms on the right side. Perfect. Our oxygen is now balanced. But wait a second. Look what happened. By fixing the oxygen, we've kind of messed up the hydrogen. Our new tally shows that the right side has 4 hydrogen atoms, but the left side still only has 2. And you know what? That is totally normal. Balancing is often a back-and-forth process. Like a seesaw, we just have one more step to go. To fix the hydrogen, it's pretty simple. We just go back to the left side and add another coefficient. We'll place a 2 in front of the H2, which gives us 2 molecules of H2 for a grand total of 4 hydrogen atoms on the left. And there we have it. Let's do a final check of our tally. 4 hydrogens on the left, 4 on the right. Check. 2 oxygens on the left, 2 on the right. Check. That is a perfectly balanced equation. We did it. So now we've accounted for every single atom. Nothing was created, nothing was destroyed.
We've just shown how the atoms simply rearrange themselves to form a new substance, all while perfectly following that big, important law of conservation of mass.
So, here is your takeaway for the test. Number 1, the law of conservation of mass is the reason we balance equations in the first place. 2, always use a tally table to keep your counting nice and organized. And 3, the big one, the golden rule. Never, ever, ever change the small subscripts. Only change the big coefficients out front.
And it's pretty interesting. This whole idea of conservation goes way beyond just atoms in a chemical reaction. It's actually a fundamental rule for how the entire universe works, applying to things like energy and momentum, too. It's a pretty amazing concept when you stop and think about it.